All right, we're going to start with our video on chapter 1.2. And as always, whenever we start a new video, a reminder that you should pause the video at any point that you need to do some work. And we're not going to pause the speaking part of the video because you've got the pause keys on your computer. So let's start by giving you the goal. The daily target, learning target, is to evaluate expressions and identify the properties. We have some new vocabulary words to learn. A blank is a symbol, usually a letter, that is used to represent a number. And that's a variable. A variable is a symbol, usually a letter, used to represent a number. The branch of mathematics that involves expressions with variables is called algebra. And an algebraic expression contains a variable, a number, and at least one operation. Evaluate is to solve or simplify an expression or an equation. And a numerical expression is one with only numbers and operations, no variables. Order of operations is a method. Order of operations is which operation do we do first? And I've got a memory method here for you. If you remember the sentence, please excuse my my Aunt Sally, and you remember the first letter of each word. That will help you remember the order in which to do the operations. So the letter P, which is first, talks about parentheses. The letter E talks about exponents. M talks about multiplication and division in order from left to right, and the A talks about addition, the S subtraction in order from left to right. Expressions such as 7 squared and 3 or x to the third are called powers, and powers are used to represent repeated multiplications. So 7 squared is really saying 7 times 7. And x to the third is saying x times x times x. Times x. There's 3 x's, so it's x to the third. There's 2 7s, so it's 7 squared. It's a way of showing repeated multiplication. A property is a feature of an object or a rule that is always true. A counterexample is an example that shows a conjecture or a proposed property is false. The property does not apply if you can find a counterexample that shows that. Order of operations, we're going to hit this pretty hard. This is very important. We're going to perform all operations within the symbols first. Within the symbols first, and within the parentheses. We'll start with the innermost one and work our way out. We will evaluate the powers before other operations, and then we will do multiplication and division in order from left to right, and addition and subtraction in order from left to right. Example, evaluate the algebraic expression of 4 times the quantity r minus s squared. If r is 6 and s is 3. We're going to replace the r with the number 6, and we're going to replace s with the number 3. We're going to plug those things in. So our original equation of 4 times the quantity of r minus s quantity squared becomes 4 times parenthesis 6 minus 3 quantity squared. We're going to do the stuff inside the parentheses first. Do that part first. So we take 6 minus 3, of course we get 3. Now we're going to do the powers part second. So 4 squared becomes 9. 4 times 3 squared. The 3 squared becomes 9 because that's 3 times 3. 3 times 3, which gives us then 4 times 9, or of course our final answer is 36. your progress. Please do this one on your own. You can pause your recording and do the work and then come back and we'll see how we did. All right, we're going to plug in the A becomes 3 and the B becomes 2. So we've got 3 plus 2 quantity squared. We're going to do the operation within the parentheses first. 3 plus 2 is 5. Then we're going to do the powers. We're going to take 5 squared, which becomes 5 times 5, which of course 5 times 5, which of course is 25. So the correct answer is A. Please evaluate this expression. Take some time, do it on your own, and then come back and check yourself on the video. The first thing we're going to do is, of course, replace the Q with the 5 and the R with 6. So we start off with this equation, Q squared minus 4R minus 1, and it becomes 5 squared minus 4 times 6 minus 1. Then we're going to evaluate the powers next. The powers, 5 squared, which is just a simpler way of writing 5 times 5. That becomes 25, and this should say minus, got left out a negative sign there, minus 4 times 6 minus 1. The next thing we're going to do is multiply. So we've got 25 minus 24 minus 1. Now we'll do adding and subtracting in order from left to right. We've got 25 minus 24 becomes 1. 1 minus 1, of course, is 0. Check your progress. I'd like you again to do this one. This is for your practice. So when you're done with it at your desk, please check back to the video. We're going to plug 4 in for B. We're going to plug 2 in for C. So we've got 4 squared plus 3 times 2 minus 5. The next thing we're going to do is do the powers. So we're going to do this part right here. 4 squared is really 4 times 4, or 16. 3 times 2 is the next part we're going to do. So that becomes 6 minus 5. We're going to do addition and subtraction in order from left to right. So 16 plus 6 becomes 22. 22 minus 5. We actually do the subtraction next, and we get 17. So our correct answer is 17. Evaluate this expression. We've got 6Q divided by 5S. 6 times Q divided by 5 times S. The number Q is going to be 5. The variable S is going to become 3, so I plug those in. We've got 6 times 5 divided by 5 times 3. We do the numerator first. We go 6 times 5. We multiply there. We're going to get 30. We do the denominator second. We do 5 times 3 is 15. And the last step is actually to do the division. 30 divided by 15 is 2. Okay. Check your progress. If 3S divided by Q, if Q is 2 and S is 4, you've got 3 times 4 divided by the Q, which is 2. So we do the numerator first. We do the 3 times 4 first, and of course we get 12 divided by the 2. 12 divided by 2, the answer is 6. Identify some properties. We're going to go through a number of different properties. The first one we're going to do is called the identity property. And here's one example. 12 times 1 is 12. Multiplying by the number 1 does not change the number. This is called the identity property of multiplication. Identity property of multiplication. We've got some other properties we want to talk about. The first one is called the associative property. There's one for addition and one for multiplication. Associative property says the order in which we do the addition doesn't matter. We can go A plus B plus C and do that first, or we can move the parentheses and go A plus B, then plus C. And it works out to be the same answer. We're going to look at the same associative property, but this time for multiplication. And again, it says order doesn't matter. A times the quantity, B times C, is the same thing as moving the parentheses the other way and going A times B and then times C. Order doesn't matter when you're doing either addition or multiplication. The community property says that in addition, we can switch them around here. A plus B is the same thing as saying B plus A. All right, we switch which comes first. Multiplication, the same thing. The community property of multiplication, A times B is the same as B times A. Distributive property says that if we're taking A times the quantity, B plus C, A times B plus C, it's the same as saying A times B and adding it to A times C. The distributive property of, that's the distributive property of addition. Now, the distributive property of subtraction. A times the quantity of B minus C is the same as saying AB minus A times C. The identity property for addition is the number 0. A plus 0 equals A. It doesn't change the value. And for multiplication, A times 1 is equal to A. It doesn't change the value. Name the property that's shown by the statement. I've got 3 times 2 is equal to 2 times 3. 3 times 2 is equal to 2 times 3. Well, let's look back at our rules so that we can see which one we're dealing with here. The order in multiplication. Order in multiplication, I think it's referring to that one. So it's the commutative property of multiplication. The commutative property of multiplication. Okay. Found a counter example. State whether the following conjecture is true or false. If false, provide a counter example. The sum, that means addition, of an odd number and an even number is always odd. Is that true or is that false? The conjecture is true. If I add an odd number and an even number, every single time I'm going to get an odd number. State whether the following conjecture is true or false. If false, provide a counterexample. Division of a whole number is associative. If it's associative, that means that the order doesn't matter. So let's look at this. Is it true or false? If I can find an example where it's false, then I know the conjecture is false. It is false. And here's my example. 15 divided by 6 divided by 2. Is that the same thing as saying 15 divided by 6 and then divided by 2? Well, if I work this out, I've got 15 divided by 6 divided by 2 is 3. So 15 divided by 3 is 5. If I take 16 divided by, if I take 15 divided by 6, I'm going to get 2.5, 2.5. If I take that and divide it by 2, I'm going to get 1.75. Since these two numbers are not the same, this is false, and the idea of the proposed rule is false.